Good morning. This is the first chapter of the course of the mechanic bond. The first chapter is vector analysis. Firstly, we will begin with introduction. In physics, vectors are widely used to model physical quantities such as force, velocity, acceleration, or certain fields, electric, magnetic, gravitational. Definition of vector. A plane vector AB is defined by three components. The first component is direction. What we mean by direction. Direction is that of the straight line AB carrying the vector. Distance from A to B is the second component, and the third component is a module or length or norm is that segment A. Three, vector operation. We have many operations to do with the vector. The first operation is equality of vectors. Two vectors are equal if they have the same direction, the same sense, and the same module. The second operation is norm vector or module vector or the magnitude of the vector. How we can calculate the magnitude of the vector. So we consider a vector A in plane with coordinate x and y. So the vector A is xi plus yg. This component in the plane of the vector A is ax plus ay. So the magnitude, we calculate the magnitude with the rules squares x plus y like this. And the third operation is a vector addition. How we can add two vectors is the addition of one vector to another. A, B, and BC equal AC. Geometrically, what is the meaning of the addition vector? Is the sum is the diagonal the sum pardon, the sum is the diagonal of the parallelogram. We have scalar multiplication of vectors. To multiply a vector by scalar, multiply each component by scalar. Let's give vector A and A scalar or scalar pardon B. We have B scalar A or A scalar. The vector A scalar B is a vector with the same direction as A if P is positive and the signs opposite to A if P is negative, and a null vector if P equal 0. Vector algebra. Let's have A, B, and C three vector and P and Q to scalar. We have many operations we can do it with the vector. For example, the first characteristic is the commutative. A plus B is the same equal B in plus B, and associative. For example, A plus B plus C is the same of A plus B plus C. Associated that we can say B scalar K for A or dot A equal K dot P dot A is the same, or P dot K dot A. And distributive, we can distribute the sum of the two scalar P plus QA equal PA plus QA, and P scalar A and plus the vector B, pardon, we can write like this: PA plus PB. Vector is one of the vector operation. What we mean the unit vector? So the unit vector who is a vector whose modulus or the magnitude is equal to 1. So the magnitude of u, vector into u, is 1. So the A equal the module of A for the unit vector u. So how we can calculate the vector u? We can calculate the vector u with this rules: equal vector a over the magnitude of the vector a. So we can deduce the unit vector. For example, we have a vector a equal to ei, pardon, plus 3j. We can calculate the unit vector, and we have this solution: the magnitude of the A equals square root 13, and we can apply the rules, and we obtain the unit vector of the unit vector of vector A.